Hello everyone, this is Dmitry from Galileosky, and in this video I'm going to show you how to add trackers to the SCADA system in a sensor mode. While in a sensor mode, Galileosky 7X or Galileosky 10 tracker sends its data to the server according to the standard Galileosky protocol. This data is parsed with the OPC server and then used in the SCADA system. There is a short manual for receiving the data from the tracker with the OPC server on the Galileosky GitHub page. Go to the GitHub and look for the industrial folder. Then go to the master OPC folder. There are several files and a short text instruction here. As an example, we are using multi-protocol OPC server application. There is a link to the page where you can download it. Please note that the application version must be 6.09 or higher. I already have it installed. For the OPC server to get the data from the tracker, you need to add a special script that parses the Galileosky protocol. Download Galileosky master OPC.lua file and save it to the application modules folder. Among available files, you can also find the example project that uses the Galileosky tracker data. Specify the IP address of your computer on which the OPC server is running and the port for communication in the Galileosky node parameters. Please note that to receive the data from the tracker, you should have a static IP address accessible from the external network. The tracker will send the data to this address. In our case, the router automatically forwards the data that comes to the external static IP address to the internal IP address of the laptop on which the OPC server is running. Specify the static IP address of the OPC server in the tracker settings on the Data Transmission tab. After that, on the Protocol tab, select the text that the server can parse. In this example, the script only parses basic text like date and time, coordinates, inputs readings, and user tags. Please note that because of the OPC server specifics, you need to have the date and time text in the first packet in addition to the IMEI. You can even make the first and the main packet identical. If necessary, you can add the text you need to the parsing script based on the Galileosky protocol description. You can always find a detailed description of the Galileosky protocol in our knowledge base. Those are all settings for the OPC server and the tracker. To display the received data, we used simple SCADA program. Its free version allows us to receive up to 64 tags. It takes readings from the OPC server and displays the received values on the screen. In our case, we see only the last data received from the tracker. For example, there are coordinates, readings from inputs, input status and output status. Now I will disconnect the voltage from the input 0 of the tracker and connect it to the input 1. As you can see in the SCADA system, the current values showed up almost right away. Of course, the true features range of a full-fledged SCADA system is much richer. In this example, I only showing you how you can easily integrate Galileosky trackers into this system. And if you remember that trackers can work with a huge number of both wired and wireless sensors, this solution becomes truly flexible. More than that, the tracker's cost is much lower than any industrial equipment with these kind of features, which also adds to the benefits of this solution. In the next video, we will look at the second option for integrating Galileosky devices into a SCADA system, this time as a Modbus TCP server. That's all for now. That was Dmitry from Galileosky. See you later.